Hey guys, how's it going? Can everyone hear me? Can you hear me in the back? It's fine? Yeah, cool. Thanks for that thumbs up. So today I'm going to talk to you about this topic, bar graphs, how we got to where we are, where we're going to go next, and how those things are kind of related. So given the interdisciplinary nature of this gathering, I think it's probably good to point out that I'm a designer. I work at Moment. We do digital strategy and product design in New York and Chicago, and we primarily work in finance and healthcare, two really data-driven industries that kind of align with my personal interest for data visualization. And while I was living in New York before I moved to Chicago, I thought it would be a great idea, somewhat misguided, to record every single subway ride I took in the year 2015 to kind of create my own data set and see what I could learn about it. And a lot of what I'm going to talk about in these next 15, 20 minutes is about what I learned from doing this exercise. So that's kind of where that's coming from. But at the end of the day, this isn't a talk about how to make prettier charts and graphs. It's, even though I'm a designer, right, and I care deeply about that, it's more about the context in which we consume visualizations today and how the small decisions we make can end up having a really huge impact on how people are learning from the data visualizations we make and even how they explore. So to understand what's going on now and what's going on in the future, I think it makes sense to actually take a few steps back and ask the question, how did we get here? How did we get to the point where people are, making incredibly complex, crazy data visualizations, sometimes without really considering the implications of what they're making or taking the steps to make sure that what they're creating is legible or consumable by, the actual human beings on the other end. So I'll take you through a few really interesting data visualizations historically and the stories behind them. So the first kind of step when data visualization started to happen, this is actually really recently, is visualization as documentation. So understanding that a table is not, or a CSV, is not the best way for information to live, that there's actually more utility by visualizing it. And one of the earliest data visualizations on record happened in the year 1630. This is towards the end of Galileo's life, so we're starting to get high quality telescopes. Christopher Scheiner decides to point his telescope at the sun and record sunspots, but instead of describing the sunspots mathematically or using equations, he actually decides to just draw them out. Draw a circle for the sun and then fill in the dark spots where you see dark spots in the telescope. And over time, he's able to kind of capture the movement of the Earth, the movement of where he is relative to the sun, and display that using one of the first examples of a principle called small multiples. I think that's a tufty term, but really just showing multiple instances of the same visualization next to itself. And this is used today in weather, in finance, in healthcare too. So once we figured out, okay, we can take data out of the table, it got to the point really quickly where people understood that visualizing data is actually a persuasive act whenever you engage in visualizing information. There's some sort of bias or opinion that you have about that information, even if you're trying to be really, impartial, that tends to manifest. And a person who really took this principle to heart is William Playfair. This one individual in the year 1822, throughout his career, actually invented the pie chart, the bar chart, the circle chart, waterfall chart, I think, too. A lot of what we use in Excel came from this guy, and this is in 1822. The United States is older than a lot of the primary tools we use to visualize information, which is, I think, kind of crazy. So in this chart, what you're looking at is, there's obviously multiple data sets here on one sort of sheet, but you're looking at the wages of an average worker and the price of wheat. So over time, he's trying to make the argument that the quality of life of a person is increased because they're able to buy more wheat for their dollar. But because this is one of the first examples of these visualizations, he actually accompanied these with pamphlets, very dense pamphlets with very clear instructions on how he wanted you to read the visualization and what he wanted you to get out of it, and even tell you kind of what his point of view is. So we're starting to have opinions or express opinions, and we eventually kind of breach we move past it, and we start to get data sets that are just too big to have opinions on just by looking at them. We have to begin to explore data for answers. And one of the most famous examples of this is a Jon Snow visualization, which a lot of you have probably seen before. I don't watch Game of Thrones, but someone told me, if you put this slide up here, people will laugh. So I did it. And so this is the actual Jon Snow we're talking about, and this is a visualization probably a lot of you have seen, where people thought cholera was a disease transmitted through the air. Jon Snow figures out this is not the case because he visits Broad Street, where a lot of the cases were happening, and sees that, oh, guess what? There's a water pump infected with human feces, and turns out that cholera is actually bacterial transmission, not through the air, and epidemiology is born. So we have writing down data for the first time, having an opinion about data, the beginning of sort of data exploration. In all of these instances, data visualization is evolving alongside the complexity, the information, and the technology available at the time. You start to have telescopes, you get people doing small multiples, you start to have people living in really close quarters, and disease kind of starting to travel between people, you start to get epidemiology. So the field of data visualization has actually evolved alongside these three things, and if we go to the present, if we go to today, we can actually figure out where data visualization is going to go based on these three kind of factors. So no surprise to anyone in this room, data and technology are going crazy. They're evolving at a breakneck pace. There's been an explosion in our ability to both create data and document it. So a couple of really interesting examples here. You may or may not know this, but the plane engines on the planes a lot of us took to get here are actually leased by the companies that own the bodies for the planes, and GE leases a lot of them, and they actually use they transmit 10 gigabytes per second of data from those plane engines to data centers that are then analyzed. Timing data, systems data, all sorts of stuff. It's crazy. But there's also data available to civilians in huge quantities, right? New York City has open data, IMF has open data, NASA, a lot of organizations are open sourcing their information, which is great, but kind of going in the opposite, a trend moving in the opposite direction is data literacy, especially here in the United States. It's getting worse and worse. So when you take these two trends and you kind of directly juxtapose them to one another, it's apparent that we're struggling to keep up with this, massive information, which is a problem. So what do we do about it? What's the solution to this problem? There's a really, really great opportunity here to take advantage of the fact that we live in the future, but kind of work around some of those difficulties. And as I was putting this talk together, I ran into this Stephen King quote, which is that if you don't have the time to read, you don't have the time or tools to write. And this translates really well to the point I'm trying to make here, which is that we need to consume a lot of data visualization ourselves to be able to create better for other people. We need to be able to understand how we perceive as people so that we can be better at creating for people. So this first half here, understanding how we perceive. The way that we see, the way that humans see is rooted in evolution, right? So I think I actually saw this on a Penn and Teller show. They went through this example, which is really cool. But if you're, let's say you're looking for, buffalo in a field because you're hunting buffalo in the Great Midwest, which is where I'm from, you might see 5 in the distance. And if you see 5, you'll know that it's 5 immediately without having to count. But if you see a much larger number, a herd of buffalo, for example, that are scattered, you wouldn't be able to tell me immediately how many are here, like you would with 5. And that 5 or 6 number threshold is really, really important for organizing and grouping information, because if I take this chunk and I break it out into sets of 4 or 6, you can instantly count way faster, just because things are visually organized relative to each other, but I can influence how you count. So right now you might be seeing, 6 rows of 4, but I can change the way you're looking at those rows just by changing the shape or by changing the color. So the small decisions that we make with space, changing color, rhythm, all of those things have a really huge impact on how information is consumed. But more so than what is there, it's also what isn't there, right? So being able to question the context or think critically about what it is we're seeing is really important. This is an example that I really enjoy, but it's kind of hard to read. So what you're looking at here is a chart of cigarettes smoked by worldwide lung cancer rankings. So, the fewer cigarettes you smoke, the less lung cancer you have. Generally, the trend kind of makes sense, but there's 2 countries here that jump out, Japan, which is right here, and Azerbaijan, which is right here. They smoke roughly the same number of cigarettes, but Azerbaijan has way less lung cancer. So you might think to yourself, why is this? Is there something in the air? Is it genetic? We need to explore this problem further. And a lot of visualizations kind of are omitting that critical piece that you need context to understand. So if you add another layer of data here, and I know gradient color overlays aren't always best practice with scatter charts, but you can actually see that Japan, if you look at life expectancy, has the #1 life expectancy in the world at 83 years, and that Azerbaijan is much lower at 70. When you find out that the average age of a lung cancer diagnosis is 71 years old, you find out that a lot of people in Azerbaijan are just passing away before they're able to even be diagnosed with lung cancer. So as people who are visualizing information, taking that extra step to kind of understand what it is we should be communicating and making that apparent is really key. And this is only going to get harder because right now, we're the ones working on creating these visualizations or generating them, but very quickly we're going to get to a point where that's not the case, where you plug in some numbers, some models into TensorFlow, and what you get out on the other end is something that is really a product of the biases of the model you've created. So you're taking these biases that normally humans are responsible for, and you're abstracting them 2, 3, 4 levels, and whatever comes out, it's really hard to evaluate. Especially, so this is, I don't know how many people in here use TensorFlow. It's machine learning library by Google, but this is a kind of a companion web app to that, TensorBoard, which you can use to better understand how your models are learning through all of the iterations or epochs that you're kind of letting them run for. And a study actually just came out last week that these charts and human input has being able to sort of iterate through this through visualization has a huge impact on the outcome of the model. But it's not just happening in 2 dimensions, it's also happening in 3 dimensions. So this is a hello world in a visualization in machine learning where you take 10,000 digits and you kind of sort them into, you use supervised learning to see kind of like what a digit is when you write. And this is really interesting because you can see that the 8s are green, but there are a few 8s that wind up where the 5s are because they look like 5s. So you can kind of understand how your model is learning, which is really, really amazing. So seeing critically is about recognizing what's missing as well as what's there. And we need to be able to see critically to understand how we consume so that we can get better at creating for people. So there are 3 questions here that seem really, really obvious and low level, but they're questions that are really important. So I'll take us through kind of what the implications of these questions are and how we can ask them more in our own work. So this first question is, should this be visualized even at all? I think a lot of times when we're handed a data set with the prerogative to make something visual, we just do it. But that's not always a good idea. And here's an example of when it's a bad idea on the simple end. So for those of you that don't know, the lines in New York, 2 of them are the D and the 6 subway line. And I would ride these lines every week. So you're looking at the total number of times I rode the train on a given day of the week. And for me, whenever I look at this chart, all I see is this. Even if I'm trying to look over here, my eyes eventually just swoop back up to that top, and it's unavoidable. And that's great if you're trying to make that point, but it's bad if you're trying to show that data. So if it's less than 20 points, less than 20 data pieces, just make it a table. It lets people see the actual numbers. It's simpler, takes less time. You represent things clearly. And I can still see that there's a 32 in Tuesday, but that doesn't take away that there's a 15 and 25 in Sunday. So, and it also absolves you of all these decisions like labeling, color, scale, how are we going to import these data libraries? You just have to deal with a lot less of that. You can also go too far on the opposite end and have things be way too complicated. So if you have, if you're trying to show too many variables, or if you're trying to take data and jam it into a visualization that doesn't necessarily accept it, that it can be really, really frustrating. And a lot of times this happens because we don't necessarily have a clear objective of what we're trying to show. So if you're ever in a situation where you're looking at something like this, taking a step back and just asking, what am I trying to do here? Can actually help a lot. So in this instance, I'm trying to show, on days when I took the train a given number of times, what mix of lines did I ride on that day? So taking a step back and just, rejiggering it and figuring it out can help. Another question that's really good to ask, and a question that user research can actually help you solve, if you're into that sort of thing, is the assumptions that you're making, because we all make assumptions. That's kind of something you have to do when you're designing, because you never have all the information. So even in a really innocuous looking visualization like this, I'm making the assumption that green and red don't mean good and bad, that they're actually associated with the 1, 2, 3, and 4, 5, 6 subway lines. And if you don't live in New York or have never been or don't care about the New York subway, you might think, oh, there's more green than red here, so something good is going on. And then you get confused trying to figure out what I'm trying to tell you, but because it just doesn't make any sense if you think about it that way. So making a really simple change and just changing colors to be something more neutral, something that people don't have associations with, is really helpful. And this happens a lot, especially when you're designing visualizations for audiences in different countries or different cultures where certain colors have certain associations, and we just don't even know about it. You can also, if you're looking at a pie chart like this, I'm making a ton of assumptions here, even with something really simple, and even though it is an exploration, right? I'm assuming that I'm making it for an artistic exploration, not necessarily a scientific exploration, that I don't need labels, that you can see or care about all of these small slivers when you really might not. And you can take things, after looking at all these assumptions, you can take it and simplify it and say, you know what, I'm just going to take all of those slivers, pack them into one of their own slices, group all of the labels, and all of a sudden that gives me more room to actually label things correctly. So thinking about the assumptions you're making, who they're for, those will inform the changes you're trying to make. And then finally, what you're trying to depict. And this is also, it might seem really basic to a lot of you in this room, but a lot of designers that I know, this is a question you struggle with a lot. If you're trying to show a relationship kind of among items, if you're trying to show a relationship over time, a distribution or a comparison, those are, I think, the four really most basic types of relationships, but they can also be combined, mixed and matched, and being able to, I think something that's really great that was hit on earlier is just being able to write out a sentence with what it is you're trying to show, and then think about, okay, is what I just wrote out a comparison among items? Is it something that's related to time? Is it both? If I'm combining them, how am I going to do that? Being intentional about those decisions will really go a long way. So those three questions, should this be visualized? What assumptions am I making? And what am I trying to depict? These are really great questions to ask. They're really great questions to ask whenever you open up a tool to start creating data visualization, especially towards the beginning of the process. But they're also really great questions to ask whenever you're consuming a visualization that someone else made or giving someone feedback, if they're a colleague or coworker, thinking about, should this have been visualized in the first place? Is this even appropriate to be a data visualization? What assumptions did this person make? Trying to think about things from their point of view. If they're a reporter working for a certain news organization, and that organization is either right wing or left wing, what are some of the assumptions that person might make, or what are the biases of that publication? And then finally, what are they trying to depict? Understanding that, at least for the time being, they're humans on the other ends of these data visualizations, and that that person has an intent which you can think about, assuming that they're at least somewhat reasonable. What are they trying to show me? What are they trying to convince me of? So I think if we can ask these questions whenever we're making or whenever we're consuming, it'll let us really be more critical, and that'll let us create more thoughtfully. Thanks. Questions, concerns, accusations? Yeah.
I was just curious what process you use to encode the information.
Sure, that's a great question. So I used Excel. So I used an app on my phone called Logger, where you can actually manually log whatever information you want whenever it happens. So every time I got on a train, I would pull my phone out of my pocket, note the line, note the time of day, and write it down, which interestingly helped me understand that even if you put yourself in charge of encoding all of your data, you're going to miss days, make mistakes, stuff's going to go wrong. Like, it's really hard to get it right. So then putting it into Excel, messing around with it, doing a bunch of VLOOKUPs, and then there's a really amazing thing you can do, which if you generate a chart in Excel, you can actually copy and paste the vectors into Illustrator or any other Adobe program for free. Keeps all the geometry, and then you can take that geometry and make brushes out of it to the strokes of shapes and do all kinds of crazy stuff. So that was this particular project. Yeah.
So when you're sort of designing with styles of charts that are maybe like not as common, like for example this one here is fairly new to me. Is there some sort of like rubric or something that you, because like when I look at this, I see essentially you took a lot of subway rides.
Mm-hmm.
Like that's what it tells me initially, but is there like like you were saying, like basically how do I know that people are going to understand this or be able to use it, functionally? Is there, when you're sort of focusing on these new types of charts and graphs, is there?
Yeah, that's a great question. I think there's two parts to that. The first part is being really diligent about collecting inspiration or things that inspire you or things that you think are working well, even if it's not necessarily for what you're working on right now. So I have a huge folder on my computer with a bunch of visualizations that are non-traditional and are really interesting that I found or people show me, and I just collect them. And then when it comes time to actually make something that's new, you can reference that folder, look at things that you like a lot, and start to mess around and put things together. And then once you've done that, actually taking someone, pulling them aside and asking them in a sentence, describe what you see here, and then having them tell you will allow you to kind of to iterate over what it is you're doing and try and come to a solution that kind of is satisfactory. That's what I would suggest. Yeah.
So one of the bigger challenges there is sort of cognitive interpretation of visualization. How do you approach accessibility? Do you have any guidance on that?
Yeah, that's a good question. Earlier this year, I was working on a project for a medical chart, and our client told us that it might have to be faxed, so we ended up printing it out and faxing it to ourselves to see if it held up. There actually are pretty great tools that integrate into some design platforms for accessibility. So just last week, I don't know if you know about Sketch, but it's a really popular vector editing tool, kind of like Adobe Illustrator, and it's pretty affordable, and there's a really great community around it. And just last week, someone released a package that allows you to test color blindness and low resolution accessibility and basic contrast, even beyond just color. With all of your designs. So looking at, I don't know if that's exactly what you're asking about, but finding a plugin like that for your software application and plugging it in. And then if you're designing something for print or for slides, putting it in that medium as you design it on a regular basis to kind of check to see if your colors are actually rendering how they should render, or bringing someone in to actually use the design and ask them if it's working for them. All right, I think that's the end of my time here. If you want to come yell at me, I'll be here. Thank you guys so much. I appreciate it.